Question number 3, f of x equals 1 over x minus 3. So the domain of f equals r difference 3. Then we find f dash of x. So f dash of x equals, here we have a fractional function. So its first derivative equals the denominator x minus 3 multiply the derivative of numerator, which equals 0, because the derivative of any constant equals 0, minus the numerator, it is 1, multiply the derivative of denominator, which equal 1 minus 0 over the denominator square. So we simplify it. So f dash of x equals x minus 3 multiply 0, it is 0. Negative 1 multiply 1 equals negative 1 over x minus 3 whole square. And here you can say that f dash of x is undefined when x equals 3. So f dash of x is undefined when x equals 3. But 3 doesn't belong to the domain of f. So there is no critical point when x equals 3, and f dash of x not equal 0. So there is no critical point. There is no any critical point. Okay, now we will determine the increasing and decreasing intervals through the number line using the sign of f dash of x. So we draw the number line here. And we write x, f of x, f dash of x. When x equals 2, when x equals 3, here f dash of x is undefined. And we'll choose some points including belongs to the interval from negative infinity to 3. We choose the number like 2. It is less than 3. And we calculated f dash of 2 equals negative 1 over 2 minus 3 power 2. And we determine its sign. It is always negative. Negative 1 over 1, it is negative 1. And we put the negative sign here. And you can say that the function f is decreasing on this interval here, and we choose another point greater than 3, like 4, and we calculate f dash of 4, which equal -1 over 2 minus 4 all square. And you can use calculator. Here we have -1 and -1 over 4. So it is -1 over 4, and its sign, it is always negative. And also the function f of x is decreasing on this interval. And we write here the function f is decreasing on the interval from -infinity to 3 and from 3 to infinity, open intervals. Okay. Question number 4. Here we have a radical function f of x equals 2x minus 3, and always in first step we must determine the domain. So what is the domain of f of x? Put 2x minus 3 greater than or equal 0. Then 2x is greater than or equal +3. It means x is greater than or equal 3 over 2. So the domain of f equals, close the interval, 3 over 2 to positive infinity. And now we determine the sign of the function. How? First we calculate the first derivative. So f dash of x equals 1 over 2 square root of 2x minus 3 multiply the derivative of 2x minus 3. What is the derivative of 2x? It's 2. And the derivative of -3 is 0. Here, so f dash of x equals, here we have 2 minus 0, it's 2 over 2 equals 1. So you can simplify it. So f dash of x equals 1 over square root of 2x minus 3. And f dash is undefined. F dash of x is undefined. When x equals 3 over 2. And note that 3 over 2 is belong to the domain. 3 over 2 belongs to the domain of f. So there is a critical point when x equals 3 over 2, and the critical point is critical three over 2, and f of 3 over 2, which equal 3 over 2, and f of 3 over 2 equals 0. So this is the critical point. Okay, now we're going to determine the increasing and decreasing intervals for the function f. For that, we will draw a table here. Like this, and we study the sign about the point 3 over 2 here, like this, and we write x, f of x, f dash of x. Here we have the point 3 over 2, and f dash of x is undefined. Okay. Now we take any number including to belongs to the domain of f of x, and the domain starting from the point 3 over 2 here. So we only choose a number belongs to the interval from 3 over 2 to infinity here. Any number greater than 3 over 2, like 2. Okay, so we calculate f of 2 to determine f dash of 2 to determine its sign. F dash of 2 equals 1 over 2 square root of 2 multiply 2 here instead of x minus 3, and the result equals 1 over root 1. It is positive 1, and here the sign of f dash of x, the first derivative, is always positive through this interval, and you can say that the function is increasing here on the interval 3 over 2 to infinity. So the function f is increasing on the interval from 3 over 2 to infinity. Okay, and go to next question. Next question here, f of x equals square root of 4 minus x. So first we must determine the domain. So put 4 minus x is greater than or equal 0, then negative x is greater than or equal negative 4, dividing both sides by negative 1. So x is less than or equal 4, and the domain of f equals the half open interval from negative infinity to 4. Now we will determine f dash of x. F dash of x equals 1 over 2 multiply the root of 4 minus x multiply the derivative of the quantity under the root, which equals 0 minus 1. So f dash of x equals negative 1 over 2 square root of 4 minus x. Okay, and the f dash of x is undefined when x equals 4, and note that 4 is belong to the domain. 4 belongs to the domain of f. So there is a critical point when x equals 4. Which is 4, and f of 4, which equal 4, and f of 4, substitute x equals 4, you will get 0. And we study the sign of the function. The sign of f dash of x, here f dash of x equals negative 1 over 2 root 4 minus x. So we draw a table like this here. And we write x, f of x. Here we have f dash of x when x equals 4, here f dash of x is undefined, okay, and we study the sign through the interval from negative infinity, here from negative infinity to 4. Okay, we'll choose a number belongs to this interval. like 3 here, and we find f dash of 3. F dash of 3 equals -1 over 2 square root of 4 minus 3, which equal -12. Okay, so the sign of f dash through this interval is negative, and you can say that the function is decreasing through this interval. So the function is decreasing through this interval, and we write it. So the function f is decreasing on the interval -to 4. Okay,